The last thing that I'll talk about before getting into DC circuits with capacitors is this idea of an ideal versus real EMF. Up until now, every time we talk about an EMF, we can assume that it's ideal. And so we're really just introducing the idea of a real EMF. And a real EMF has an internal resistance, R int, within the terminals. An ideal EMF has a symbol in the circuit as shown. We've already looked at this. The difference then with a real EMF is that there is also an internal resistor. So we have the EMF, but we also have this R int. And the key point, the thing that you need to do to make sure that you can set up and solve these problems, is to draw the circuit diagram with R int. Don't forget to include the internal resistance. If we look at our most basic example, the flashlight, with an ideal EMF, you just have the EMF and the resistor, and then current, in this case, would flow clockwise from the positive terminal to the negative terminal, and it goes clockwise through the resistor. If I do the loop rule on this, the EMF minus IR is equal to 0. And the change in potential across the resistor is equal to IR. If I isolate IR, then I have just that the EMF is equal to IR. And that potential difference in most flashlights is related to the brightness. So the brightness of this flashlight depends only on the EMF. When I draw the circuit with a real EMF, I have to include that internal resistance. And then the terminals of this real EMF are points A and B. And again, the reason for doing that is to show or to highlight that the internal resistance, R int, is within the terminals of this EMF. The current will still flow clockwise. And if I do the same loop on this, I start at A, go up to B, and then go clockwise back to A. I have the EMF minus I R int minus IR equals 0. Then if I again isolate for IR, which gives me the potential difference across the resistor, which is typically the lamp in the flashlight, then I have that IR, which is the voltage and related to the brightness of the light, is equal to the EMF minus I times R int. So the brightness of the bulb in this case not only depends on the EMF, but it also depends on the current. The problems can get more complicated than that, but not really. The key thing of drawing the circuit diagram with the internal resistance before you solve, that's really the key idea. The rest of it just depends on being able to accurately come up with the loop equation and then consistently work with algebra.